All right, class, welcome back to our unit on circles. Yeah. So we're going to tackle today the lesson on chords and arcs. So we're going to do a couple of videos. The second one might be long, so I'm going to cut that one down. But we're going to talk about chords and arcs today. And so what we're going to do is figure out how we can use congruent chords, what that is, how we can find the length, and I don't know if we're going to get into diameters and measurements, but there's a lot of cool stuff with chords and arcs, what happens in circles, and we'll dive right in with notes. Yay! So the notes are kind of complicated. I've highlighted some of the important words so that we can get to know like these. I mean, they look kind of intimidating, but we can really make it easy when we just focus on words. So this first diagram, you have like central angles going on and arcs going on, and here's the deal. So within a circle or congruent circles, this is what you got to know. If you have congruent central angles, you got congruent arcs. That's what you got to know. And if you got congruent arcs, guess what? You got congruent central angles. So what this is talking about is central angles and the arcs that they make. Okay, so congruent central angles means congruent arcs. Congruent arcs means congruent central angles, and that's that note. So we got to remember that. So that's neat vocab there. The next one's very similar, but now what's happening is we take that whole concept with central angles and arcs, but now we're making chords, right? If you remember, a chord is made up, it's a piece of a secant. So from the previous lesson we talked about tangents and secants, the piece of a secant is a chord. So now we have these chords coming here, right? BA is a chord and CD is a chord, and so that enters the picture and more notes. If we have congruent angles, then we have congruent chords. Isn't that cool? And if we have congruent chords, we got congruent angles. So again, we're talking about central angles. So if we have congruent central angles, we have congruent chords. And that makes life a whole lot easier when we're talking about what's going on inside of circles. But wait, there's more. So now we have another thing going on. So here we have two chords and nothing going on in between them. So what do we know? If we have congruent chords, we have congruent arcs. So there's that note too. If we have congruent chords, so for example, if here BA and CD were congruent, if we have congruent chords, we also have congruent arcs. Okay, so the arcs that the chords make are also congruent. So we have to know that, that little piece as well. And then lastly, for the notes, if we have equidistant chords, right? If chords are equidistant from the center, then they are congruent. What? That's right. So if chords are equidistant from the center, if chords are equidistant from the center, they are congruent. So congruent chords are equidistant from the center. So all these notes that have to do with chords, and there's more, but we'll wait for the next video. So central angles, congruent, arcs congruent, central angles congruent, chords congruent, chords congruent, arcs congruent, and congruent chords equidistant from the center. Cats, this is crazy. What does that all mean? I have to memorize all of that? Well, kind of, but you'll start seeing there's a lot of, it's almost intuitive congruence that goes on. So it's almost intuitive, but it comes with practice. So you have to pay attention to what's going on with practice, then you can figure some things out. So take, for example, this first problem that we'll work on. So in this diagram, we have two congruent circles, right? Circle O is congruent to circle P. So these circles are congruent, which means already that OB and OC being the radii are congruent to PD and PF being congruent. So they're the radii. The radii are congruent if the circles are congruent. But now we're going to have a piece of given information. It's saying given that BC is congruent to DF, right? If BC is congruent to DF, what can we conclude? We can conclude a whole bunch of stuff from the notes. We have a congruent chord. So congruent chords makes all sorts of stuff congruent. Congruent chords means the arcs are congruent. The arcs are congruent means the central angles are congruent. So all sorts of neat stuff. Or we could have jumped right into chords and central angles. So we can conclude a bunch of congruence happening here. So we can first say, let's say that so the measure of arc BC would be equal to the measure of arc DF. That's what we can conclude, right? BC and DF. And we can also talk about the central angles being congruent as well. So like I say, it's almost intuitive, but not so much. So we can say that, that angle BOC is congruent to angle DPF. So we can make those two conclusions based off of just that given information of BC being congruent to DF. Let's take another example. This one's not as straightforward, but hopefully we can get there. So suppose we're given the two circles congruent, circle O, circle P. And now, check out this piece of information. With angle OBC, which is right here, angle OBC being congruent to angle PDF, which is right here. What can we conclude? How can we show that angle O is congruent to angle P, and then what else can we conclude? Well, this is kind of interesting because we have to know a couple things. Remember we talked about in the first example, when we know that our circles are congruent, we know that the radii are congruent. And that is a pretty significant thing to understand. So we have to understand that from O to B is a radius, O to C is also a radius, and the radius doesn't change. It's the set of all points equidistant from the fixed point. So in a circle, the radius does not change. So the radius is the same. And if the circles are congruent, that means the radii are congruent. And so I can pause right here, and you can say, yeah, so what? Cats, I know, because I remember my triangle congruence, that if we have angle side side, that doesn't prove anything. That's true. Angle side side doesn't prove anything. But here's what we're forgetting, possibly. When we look at our two congruent sides, what do we have? Congruent sides means we have an isosceles triangle. So with the isosceles triangle, we know that we have two sides congruent and the opposite base angles are congruent. So now we know the opposite base angles are congruent because it's isosceles, and with that we have our congruent triangles, and with that we have our congruent angles that we're looking for. Okay, so angle O being congruent to angle P has to do with isosceles triangles. And so what else can we conclude? We can also conclude that the arc measures. Okay, so arc BC is congruent to arc DF. Okay, so arc BC is congruent to arc DF. We can also conclude that. So that's some neat stuff. That's some neat stuff that we can figure out from the notes. All right. So remember the notes here. We got to remember that. All right. So there's one other note we have to cover, and then we'll be done with this particular video. So one last note. We were talking about chords. Congruent chords are equidistant from the center. Okay. So congruent chords are equidistant from the center, and if we have chords that are equidistant from the center, they are congruent. That's the deal. So in this example, we're going to figure out what the length of RS is. Now, segment RS is a chord that goes from here to here. How can we figure out what that length is? Well, we know from that last note, congruent chords are equidistant from the center, and chords equidistant from the center are congruent. Oh my gosh, I have to say all that stuff? No, but still, it's good to know. So we look at circle O, and the distance from circle O to the chord RS is 9. And the distance from circle O to chord PR is also 9. That means they are equidistant. That's what that means. And if they are equidistant, that means they are congruent. So what this means is that chord PR is congruent to chord RS. That is what that means. So if we know the distance of PR, then we know RS. And can we know that? Well, yeah, take a look at here. What's given in the diagram is that the distance from P to Q is 12.5, and the distance from Q to R is congruent. So that means we have 12.5 plus 12.5, which is, as we know, 25. So if we know our distance is 25 for PR, then we know our distance is 25 for RS. So, of course, the answer, 25. All right, so hopefully that makes sense. Equidistant chords are congruent. And that makes this last one a little bit easier. So it says, what here is the value of x? Well, we have two chords, right? And what are the measurements of the two chords? Well, the chord here is easy. It says 36. That's convenient. What is the length of this chord here? That's 18 and 18, which is also 36. So those chords are congruent. If the chords are congruent, that means they are equidistant from the center. So if the distance of the center of one of the chords is 16, guess what the distance from the center of the other chord is? Also 16. So if we know those notes, we can really navigate our way around chords and arcs. And that's enough for now for this video. We'll come back with some more stuff about chords and arcs as well, and I'll see you soon.